Hello, class. This is Mrs. Lyons, and we are getting ready for our test on single and double replacement. And I thought I would go through what you are going to see, what kind of questions you're going to see on the test. All right. So you're going to see 4 reactions. 2 will probably be double replacement, 2 will be single replacement. All right. You will have to predict the products. So before we get started, here's what you need to make sure you have out. You will need your periodic table. You will need your activity series for our single replacement reactions. And you will need our solubility rules for the double replacement reactions. So let's get started. All right. So the first thing that is going to be important to do is to identify what type of reaction you are looking at. Okay. And to know that, what you need to remember about single replacement reactions is the generic formula was AB plus C. Okay. So in other words, we have a compound reacting with an element. All right. One of the elements is going to replace the other depending on the activity series. The second type of reaction, double replacement, generic formula is AB plus CD. So we have 2 compounds in this reaction. Okay, so it's really important to identify the type of reaction so you know how to predict the products correctly. So if we look at number 1, we have lithium, which is an element, and we have aluminum oxide, which is a compound. Okay, that tells us that this is going to be a single replacement reaction. All right, in a single replacement reaction, you look at the element and you compare it with the other similar element. Okay, so I mean, if it's a metal, you compare it with a metal. If it's a non-metal, you compare it with a non-metal. But you're going to compare it in our activity series. So in this case, we're looking at lithium and aluminum. Okay, lithium is higher on the activity series, which means lithium is more reactive. And what that means is lithium does not like to be alone. It's not stable on its own. It wants to be in a compound. So since lithium is higher up, lithium is going to take aluminum's place. So our products are going to be lithium oxide plus aluminum. Okay, so now that we've got that, we need to write this into a chemical equation. All right, and the thing that it's going to be important to do, so let's start. Lithium is just an element. So when it's an element, we just do one single atom of that element, unless it's one of the 7 diatomic elements. Remember our Haber-Finkel elements. Let's write those up here. Okay, if it was one of those, it would need a subscript of 2 because it's a diatomic element. Lithium is not part of that. So lithium, if you look on your periodic table, is a solid. Next, we have aluminum oxide. So we have to look. Aluminum is in group 13, which means it has a +3 charge. Oxygen is in group 16, which means it has a -2 charge. All right, so for aluminum oxide, aluminum's +3, oxygen's -2, we're going to crisscross those charges and we're going to get Al2O3. All right, being able to do this, write formulas, you guys, is key for this unit. If you're still not knowing how to come up with the compound, you've got to figure that out. And the key is it's always the same. Anytime you have 2 elements combined, you have to look at the charges and crisscross them to make it be a stable compound. So this is going to be Al2O3. We said in single replacement, our compound is aqueous. All right. And then we make lithium oxide. So lithium is in group 1. So it has a +1 charge. And we said oxygen has a -2 charge. So if we crisscross, we get Li2O, the compound's going to be aqueous, plus aluminum. Just aluminum metal, so that's going to be solid. All right, now let's see, is this balanced? The answer is no. So let's see, I'm going to start with my oxygen. I have 3 oxygen on the left and only 1 on the right. So if I put a coefficient here, now I have 3 oxygen on each side. All right, I also have 6 lithium. So I'm going to put a 6 here. That's going to give me 6 lithium. And let's see, do I have everything else? Al2, so I need a 2 here. So I've got 6 lithium plus 6 lithium, 2 aluminum, and 3 oxygen. Okay, so my equation is balanced. All right. The second reaction, all right, lithium phosphate plus calcium sulfate. Those are both compounds, so this is going to be a double replacement reaction. And in a double replacement reaction, what happens is the anions switch place. So we end up with lithium sulfate plus calcium phosphate. Okay. Now remember, for double replacement reactions, sometimes they don't happen. And what we've got to do is we've got to find our compounds on our solubility table. So lithium is, remember, lithium is a group 1 metal, okay? And one of the things that is key on our solubility rules, all group 1 metals are always soluble, which means aqueous. Okay, so that means lithium sulfate is aqueous. And then calcium phosphate, if we look down here, phosphates are always insoluble, or S. All right, so our calcium phosphate is going to be a solid. All right, so that means this reaction happens. So now we got to write the chemical equation. And you guys, you now have 4 compounds. You have to look at the charges and crisscross. So lithium phosphate. Lithium, we said above, it has a +1 charge. Phosphates, okay, we're using all of our chemistry now. Phosphate is a polyatomic ion. It's on the back. PO4 with a -3 charge. So PO4 -3 outside. I'm going to crisscross. So I'm going to get Li3 PO4. Now, if you want to leave it in parentheses, you can. That's aqueous. Our reactants are always going to be aqueous. All right, next we have calcium. If I look on my periodic table, calcium's in group 2. So calcium has a +2 charge. And then sulfate is back here on my polyatomic ion chart, SO4, with a -2 charge. So I have calcium +2, SO4, sulfate -2. Since those are equal and opposite, they're going to trade places, or they're going to cancel out. So we end up with CaSO4. All right, that's aqueous. Now, lithium sulfate. So lithium was +1, sulfate was -2. So if I crisscross, I get Li2SO4, aqueous, plus calcium phosphate. We said calcium was +2, phosphate is PO4 -3. I'm going to crisscross and I get Ca3 PO4. I do need the parentheses now because I have 2 of those, and that's a solid. All right, now I need to balance. So let's look at what I've got. So I've got 3 lithium here, 2 lithium there. So that's these are one of these classic cases where we've got to get to 6 of the atom in order to be stable. So what that means is I need a 2 here to give me 6 lithium and a 3 here to give me 6 lithium. Now let's see. That's 6 lithium. I have 2 phosphates, so that's okay. I've got 3 calcium here, so I need a 3 here. So now I have 3 calcium and 3 sulfate, so now I'm balanced. All right, now you are going to see on the test some of these equations that don't have the words. Okay, I put the words in, but you can still do this without the words. Okay, it's a little trickier, but you can figure it out. Okay, so here we have calcium hydroxide and lithium phosphate, and we're gonna skip that word equation. We're just gonna do the chemical equation. Okay, so 2 compounds, that tells us this is a double replacement. Now, if I look, all right, hydroxide and phosphate are my 2 anions. Remember, anions are going to switch places. So I'm going to end up with, on the other side, I'm going to end up with calcium phosphate. Okay. Now we can't just write calcium and phosphate. Okay, because we have to look at the charges. And here's a little trick that I do when we're doing this. If we can do kind of a crisscross. Okay, so calcium, I'm going to show you how to do this. I'm going to write my compounds. I've got calcium hydroxide. Those are the 2 pieces, and I've got lithium and phosphate. Okay, what you can do when you just have the formulas is do this crisscross thing. So my compound over here is going to be calcium phosphate, and my second compound is going to be lithium hydroxide. Now, the problem with that is we have to crisscross charges. Okay, so calcium is +2, phosphate is -3, hydroxide is on the back of your table, it's -1, and lithium is +2. All right, so that means calcium phosphate is going to be Ca3 PO42. Look at that. I made the same compound on both. So we already know that that's a solid because we already looked it up. And then I have lithium hydroxide. They're both 1. So let's look at our solubility table for hydroxides. Notice that hydroxides are insoluble except if they're with a group 1 element. So since lithium is here, this is going to be aqueous. All right, now let's see, balancing. Can I balance this? Let's see, I need 3 lithium, I need 2 hydroxides. All right, let's see. I have 2 phosphates, so let's go with that. 2 phosphates here, only 1, so I'm going to put a 2 here. That tells me I need 6 lithium, which means I need 6 hydroxides, so I need a 3 here. All right. So that should be balanced. Okay. One more example, bromine and sodium iodide, excuse me. All right. So this one is a replacement, a single replacement, but it's using the little short list, fluorine, chlorine, bromine, iodine. Now, if you look at just the equation, you can look at bromine versus iodine. Iodine's on the bottom, so bromine is more reactive. Okay, so bromine is going to take iodine's place. So we're going to end up with sodium bromide plus iodine. Now you got to think about all these things. Okay, sodium is +1, bromine is -1. So this is fine. NaBr is perfectly fine. All right, that's going to be aqueous. And then iodine is finally, we're seeing one of our Hobber-Finkel 7. This is a diatomic when it's but just the element. So that's going to be I2, and that's a solid. All right, and then I'm just going to pop a 2 here and there to give me my coefficients. Now, here's something to remember. When you're looking at the activity series, okay, if the element by itself is not higher up on this list, the reaction won't work. So for example, let's just say we had a reaction of zinc plus lithium chloride. Okay, lithium is here, zinc is here. So lithium is higher up. Lithium needs to be in the compound. Lithium is in the compound, so I'm going to write NR, no reaction. Okay, so we didn't see one of these on this practice test, but I think you will on the test. So just be aware of that. Okay, this question seemed to give people a ton of issues on the quiz. Okay, here's the thing. There's no, you don't have to do any math to do this question. Okay, you just have to know what to look for. So this is saying iron reacts with chlorine to form iron 2 chloride. Okay, we don't need to write the equation. We just are trying to figure out what is the limiting reactant, excess reactant, and theoretical yield. So this says the iron produces 15.3 grams. Okay, so what that means is if it were up to the iron, 15.3 grams of product would be made. The chlorine could produce 10.5 grams. Okay, so if all of the chlorine got used up, we would make 10.5 grams. Okay, remember the limiting reactant is the one that runs out first, so it's the one with the lower amount of product. So in this case, our limiting reactant is going to be chlorine, and our excess reactant is going to be iron, and our theoretical yield is just what's produced from chlorine, so 10.5 grams. All right, so that one was like a word problem that you really didn't need to do any math. All right, okay. Now we have one stoichiometry problem. It's going to be a limiting reactant problem. The first thing we need to do is balance this equation. I see 2 chlorine, 3 chlorine, so I'm going to do the times 6. All right. Okay. Now, what is the mole ratio of aluminum to calcium? So aluminum is 2. Calcium is 3. Okay, that's all that's asking. All right, so now, if 198 grams of calcium and 481 grams of aluminum chloride react, how many grams of aluminum would be produced? Okay, this is where you're going to do those 2 gram to gram calculations. Okay, so gram to gram, if you even if you aren't good at stoichiometry, the moles to grams, grams to moles, gram to gram is always the same. You're going to do 3 steps. Okay, so let's start with 198 grams of calcium, always over 1. All right, the first step is to convert grams of calcium to moles of calcium. So 1 mole of calcium goes on top, and we want grams of calcium on the bottom. When we want grams, we're always going to look at our periodic table. The molar mass of calcium is 40.08 grams. Okay. So grams will cancel out. All right, this will give us moles of calcium. Now we need to use our mole ratio to look at the moles of calcium. We need to convert from moles of calcium to moles of aluminum. So I'm going to look up here in my equation. 3 moles of calcium will produce 2 moles of aluminum. All right, so our moles of calcium cancel out. And then our final step is to convert moles of aluminum to grams of aluminum. So 1 mole of aluminum. Anytime we want grams, we've got to look at our periodic table. So aluminum molar mass is 26.98. Something else to keep in mind, okay, when you're doing this stoichiometry calculation, the coefficients of the chemical equation only matter in the middle step. Okay, what that means is when we're converting from moles to grams, we only want 1 mole. So even though there's 3 calcium up here, I'm just going to use 1 mass of calcium. Okay, all right, so let's do this calculation. All right, so let's see, 198 divided by 40.08 times 2 divided by 3 times 26.98 is 88.86 grams. 88.86 grams of aluminum. All right, now we need to do the exact same calculation, only we need to start with aluminum chloride this time. So 481 grams of aluminum chloride over 1. Okay, so the first thing we need is the molar mass of aluminum chloride. All right, so let's just calculate that up in this space up here. So aluminum is 26.98, chlorine is 35.45. I have 3 chlorine, so let's do 3 times 35.45, 106.35. And then aluminum was 26.98, 133.33. All right, so that's going to go down here, 133.33 grams of aluminum chloride. All right, next step is our mole ratio step, where we go from moles of aluminum chloride to moles of aluminum. All right, so up here I've got 2 moles and 2 moles of aluminum, 2 moles of each. All right, now remember, we're always wanting our units to cancel out. So far so good. I didn't cancel up here, but they do cancel. And then finally, we want the molar mass of aluminum. So 1 mole of aluminum is equal to the molar mass, 26.98 grams of aluminum. And that will let our moles cancel out. All right, let's do this calculation. 481 divided by 133.33 times 2 divided by 2, that cancels, times 26.98. 97.33 grams of aluminum. Okay, now that you have this, okay, now we need to answer some questions. Okay, so what you need to look at is which of these numbers is smaller. So in this case, 88.86 is smaller. So what that means is 88.86 is your theoretical yield. So 88.86 grams. All right. Now, what you've got to do once you know your theoretical yield, once you find the smaller, you look back where you started. And we started with calcium. Okay, what that means is calcium is our limiting reactant. It runs out first. All right, so that means that aluminum chloride, the other reactant, is excess. All right, and then finally, we want to calculate our percent yield. So this tells me if I went into the lab and made 1.12 grams of aluminum, what would my percent yield be? All right, so I'm going to use actual over theoretical. So 1.12 divided by 88.86 times 100. It's a really bad yield. 1.12 divided by 88.86 times 100. A 1.3% yield. That is not a good yield, but it happens, believe it or not. All right, so that was a quick run through of the types of questions you are going to see on the test for this unit. All right, I hope that helps. I will see you in class. Take care.